The first thing that I'm going to talk about is the formation of precipitation and explaining the differences in rain, sleet, snow, and hail. Precipitation is formed through two processes. The first process is collision coalescence, which is precipitation from warm clouds. During this process, clouds that are composed of liquid droplets must contain some droplets that are larger than 20 micrometers for precipitation to form. For these larger particles to form, there must be hygroscopic particles, or particles that attract water, abundantly present in the atmosphere. These particles begin to remove water vapor from the air when the relative humidity is under 100%, which makes the droplets begin to grow larger. The rate at which the droplets fall is dependent on the size of the droplets. Therefore, these larger droplets fall most rapidly. As they fall, they collide with the smaller droplets, which are moving slower. As they collide with these droplets, they may become large enough to fall to the earth without evaporating. These raindrops can grow to a maximum size of 5 millimeters, and when they reach this size, they fall to earth at a rate of 33 kilometers per hour. Falling at this size and speed causes the larger droplets to break up into smaller droplets, thus starting the growing process over again. The second process is the Bergeren process, which is precipitation from cold clouds. This process is based off the knowledge that cloud droplets remain liquid at temperatures as low as negative 40 degrees Fahrenheit. Cold clouds are made up of supercooled droplets and a small amount of ice crystals. Supercooled droplets are created when liquid water is at a temperature below freezing, which causes it to become a solid. When the ice crystals and the supercooled droplets are both present in a cloud, it is the ideal mixture to create precipitation. The ice crystals present in the cloud collect water vapor at a faster rate than the present liquid water. Due to this, the water droplets begin to evaporate to replenish the disappearing water vapor and help provide a constant source of moisture to help the ice crystals grow larger. The water droplets shrink in size while the crystals continue to grow. As this process goes on, it generates ice crystals that become large enough to fall as snowflakes. As they fall, they pass through supercooled cloud droplets that freeze onto them and cause them to once again grow in size. If the surface temperature is 39 degrees Fahrenheit or higher, the snowflakes will melt and fall to the ground as rain. So now we have the different forms of precipitation. The first one is rain, which is just drops of water that fall from a cloud. Then we have snow, which are ice crystals that are formed as they fall through the atmosphere with a temperature that is below freezing. It will continue to fall to earth as snow as long as the temperatures remain below freezing. The next is sleet, which is rain that falls from the clouds and freezes before it reaches the earth's surface. And the last is hail. And hail's produced only in large cumulonimbus clouds, and in these clouds they're created by an updraft that causes water droplets to go upwards and collide with other water droplets, which forms hailstones. This process continues until the hailstone encounters a downdraft or it grows too heavy to remain suspended by the updraft. Now we have the adiabatic cooling process and how clouds are formed. The adiabatic cooling process, air rises from the surface and expands, which causes it to cool. And once the air reaches the dew point, condensation begins and creates a cloud. Why airlifting is important and two examples. Airlifting is important because if air is lifted sufficiently, it will cool to its dew point temperature, saturation will occur, and clouds will develop. Two types of airlifting listed below are the orographic lifting, which occurs when air is forced to rise over a mountainous barrier, and frontal wedging, which occurs when warmer, less dense air is forced over cooler, dense air.